Sir, na name cheppanna. Good evening, students. Today we are going to discuss about differential equations. So, by the way, my name is Yugender, so maths faculty. So, today I am going to discuss about differential equations. Differential equations. So, what is the definition of differential equations? Means an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called differential equations. Yes, listen Anna carefully. Differential equations means an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called differential equations. So basically differential equations are two types. Now one is ordinary differential. So for example, see, so differential equations means what? An equation involving one dependent variable and its derivatives with respect to one or more independent variables is called differential equations. For example, now example 1, now dy by dx plus 2y equal to 0, dy by dx plus 2y equal to 0, comma du by dx plus du by dy plus du by dz equal to 0. So it is a one differential equation of the form. See, here y is nothing but what? Here dependent variable. Y is nothing but what? Dependent variable, and x is nothing but what? Here independent variable. Independent variable. So once again listen carefully. Differential equations means an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called differential equation. So example, see here, this is one dependent variable with respect to is what? Here only one independent variable. Now in this case here u is what? Here u is nothing but dependent variable. U is dependent variable. Independent variables, how many independent variables are there? Here x, y, z is there. Okay. So an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called differential equations. So these two are examples of differential equations. So once again I am repeating, differential equation is nothing but an equation involving one dependent variable. Here y is the dependent variable and with respect to is what? Here x is there. So here y is the dependent variable and in this case x is the independent variable. Now in this example u is the dependent variable and x, y, z are independent variables. So clearly already I have told, an equation involving one dependent variable and is with respect to one or more independent variables is called differential equations. So differential equations are mainly two types. Now one is ordinary differential equation. Ordinary differential equations. See here, ordinary differential equation means an equation involving one dependent variable and its derivatives with respect to only one independent variable is called ordinary differential equation. So for example here, now dy by dx plus 2y equal to 0 is there. So y is the dependent variable, and x is what? Here independent variable. So already I have told. So an equation involving one dependent variable and its derivatives with respect to only one independent variable is called ordinary differential equation. Now coming to what are partial differential equations. Now partial differential equations. Now partial differential equations means an equation involving one dependent variable and its derivatives with respect to more than one independent variables is called partial differential equations. For example, now du by dx plus du by du by dy plus du by dz equal to what is some 0 here. Here y is what here, u is nothing but only one dependent variable and x, y, z are independent variables. Okay. So mainly differential equations means an equation involving one dependent variable and its derivatives one or more independent variables is called differential equations. Differential equations are mainly two types. One is ordinary differential equation and one more is partial differential equations. So ordinary differential equations means what? An equation involving one dependent variable and its derivatives with respect to only one independent variable is called ordinary differential equations. So now coming to partial differential equations. So partial differential equations means an equation involving one dependent variable and its derivatives with respect to more than one independent variable is called partial differential equations. So these two are mainly based on differential equation definition. We can define very easy ordinary differential equation as well as partial differential equations. Now coming to order and degree. Yes, I hope all of you understood. See, differential equations means already we know that differential equations are an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called differential equations. Differential equations are mainly two types. One is ordinary differential equation and one more is partial differential equation. So ordinary differential equation means what? An equation involving one dependent variable and its derivatives with respect to only one independent variable. Only one independent variable is called ordinary differential equations. And partial differential means an equation involving one dependent variable and its derivatives with respect to one or more than one independent variables is called differential equations. Now coming to next one is order. Order means very simple. Order is nothing but so whenever one differential equation is given, differential equation is always in terms of dy by dx and x and y terms only. Now for example, dy by dx plus y equal to 0 is given. Order means this is what here, this dy by dx is means what here, we should derivative only one time. So this order is nothing but what here, first order. This is first order. And d square y by dx square plus 2 into dy by dx plus 2xy equal to 0 is given. So in this differential equation is having what here, highest derivatives means what here, this is only first term derivative, this is what a 2 times derivative. So in this differential equation is highest derivative is what here 2. So this is, can I write second order. Next I am writing d cube y by dx cube plus 2 into d square y by dx square. Now plus 3xy into dy by dx equal to 0 is given. So this differential equation is what here, first order. This differential equation is nothing but what here, second order. This differential equation is nothing but what here, third order. So I can write what here, this is the third order differential equation. And a differential equation is having what a derivative of given differential equation is called order. So here order is what here, 1. Order is what here, 1. Here order is nothing but what here, 2. Here order is nothing but what here, 3. So order means a differential equation is having what a derivative. Derivative means here only first derivative, this is second derivative, this is what a third derivative. So depend on derivative, we can say what a order. Next, degree. So here degree also, you know, order we can define very easy. Degree. Degree means what here? Whenever a differential equation is given, whenever a differential equation is given is having highest derivative is nothing, highest derivative of power or exponent value is called degree. See, for example, this is one differential equation is given. So find the order and degree of this differential equation is asking. So first you should observe what here derivative, what here only one derivative is there, dy by dx. So here order is nothing but 1. Highest derivative of exponent or power means dy by dx whole to the power what here, how much is there, 1 is there. So we can write what here degree is what here 1. So degree is 1. Degree is 1. Now in this case a differential equation is given. Find order and degree. Find order and degree of this differential equation is given. Just we should observe here. First order means what here highest derivative. In this case this is first order, this is what is second order. Listen on carefully. So first order and second highest derivative is nothing but order. So here order is nothing but what here 2. And the highest derivative of power or exponent. So here power is how much here? 1 is there. So we can write highest derivative is nothing but order. Highest derivative of power or exponent value is called degree. So here degree is how much? Degree is 1. So similarly we should take one more example. Find order and degree. Find order and degree of the differential equation dqy by dx cube plus 2 into d square y by dx square plus 3xy into dy by dx equal to 0 is given. First we should observe whenever a differential equation is given, first we should observe highest derivative is nothing but in this first order is there, second order is there and third order also there. So we want highest derivative is nothing but order. So highest derivative is what here? dqy by dx cube. That's why order is nothing but 3 and highest derivative of exponent or highest derivative of power is called what here? Degree. So here degree I can write degree is nothing but 3. Degree is what here? 1. Degree is 1. Highest derivative of power or exponent value is called degree. So these are basic examples. Order is nothing but whenever a differential equation is whenever a differential equation is given, first we should observe what a highest derivative of that differential equation is called order. In this highest derivative what a dy by dx. So dy by dx is nothing but first order. First derivative is there. So that's why first order means that that time we should say order is nothing but 1. And in this case highest derivative what here? D square y by dx square. So order is 2. And in this case what here? dq y by dx cube is highest derivative of given differential equation is called order. So order is here what here? 3. So degree means highest derivative of exponent value or power. So here for example if you take first example dy by dx plus y equal to 0, highest derivative is nothing but dy by dx only. Highest derivative of power here 1 is there. So that's why order is degree is what here? 1. So similarly second and third also. Okay. Now coming to next. Just order is nothing but highest derivative of given differential equation is called order, and degree means highest derivative of exponent or power is called degree. That's it. Now, so some examples are there. For example, I will give one example. One example. See. D to the power of y by dx to the power of 4 whole to the power of 3 plus 4 into dy by dx, 4 into dy by dx, 4 into dy by dx all to the power of 7 plus 6y equal to 0 is given. So in question is what asking? Find the order and degree of this differential equation is asking. See, in this case, this is the first order. Listen Anna carefully. This is what here first order. This is what here fourth order derivative. This one fourth order derivative. Fourth order derivative. See, but in this question is we should calculate what here order and degree. Order and degree is asking. So whenever one differential equation is given, first we should observe highest derivative is nothing but order. See, this is the first order, this is what here fourth order. Listen Anna carefully. So fourth order is nothing but which one is greater here? Fourth order. So here order is nothing but what here? 4. Order is nothing but 4. And coming to what here? Degree. Degree means already I have told just now. Degree is nothing but what? Highest derivative of exponent or power is called degree. Highest degree is nothing but what? Highest derivative is nothing but this one. It means fourth order. Highest derivative of exponent or power is nothing but degree. So here power is nothing but what here? 3. So this is what here order and degree of this differential equation. So one more example I will give. One more example. So order and degree based on we have one very short answer also there in intermediate point of view. So in MSET or mains also we have one question also there and one more question. See, now dqy by dx cube whole to the power of 5 plus, listen and carefully, and d square y by dx square, d square y by dx square whole to the power of 10 plus 2xy plus equal to 0 is given. Find the order and degree of this differential equation is asking. See, now first we should calculate what? Order and degree. See, listen Anna carefully here. A differential equation is given order and degree is asking. First we should observe what? Highest derivative. First of all we should identify mainly highest derivative is nothing but this is, I can say, second order derivative. This is second order derivative. And coming to this one, what is third order derivative? Third order derivative. See, whenever a differential equation is having highest derivative is nothing but order. So in this case, highest order is nothing but this is a second order, this is what is third order. So which one is greater? Third order only. So here order is nothing but 3. A differential equation is given highest derivative of exponent, we should observe exponent or power is called degree. Here 5 is there. Highest derivative only we should observe carefully. Listen Anna carefully. Always we should observe a differential equation is given. First of all we should observe highest derivative is nothing but in this dqy by dx cube. Immediately we should write order is 3. And degree means what? Here highest derivative of power only we should observe. So don't observe here second order also having what? Here 10 is there. But this is a second order, this is what? Here third order. So you can write third order means highest derivative of exponent or power is called degree. So here degree is what? Here 5. So this is one example. Okay. And one more example. One more example. See. Now 3 into dy by dx, 3 into dy by dx, 3 into dy by dx equal to equal to 4 plus d square y by dx square, d square y by dx square. Now whole to the power of 3 by 2 is given. Whole to the power of 3 by 2. Listen Anna, carefully. So whenever a differential equation is given, first we should observe one more important point. In RHS, in LHS, any P by Q form is there, we should convert to perfect form. Means I am writing here, this 1 by 2 I am sending to here. Now 3 into dy by dx, 3 into dy by dx. Now whole to the power of 2, that equal to 4 plus d square y by dx square whole to the power of 3. Now we should observe order means already I have told just now. Order is nothing but a differential equation is having highest derivative. We should observe highest derivative is having in RHS or LHS. RHS means this is the second order, this is about first order. So second order is in RHS side. So I can write order is nothing but 2 and degree is nothing but degree is equal to 3. So whenever a differential equation is having P by Q form is there, we should convert perfect form, either cube or either square, and it depend on question. Okay. So this is the one important note here. So this is order and degree, just basic definition. First, differential equation means mainly two types. One is ordinary differential equation and partial differential equation. Ordinary differential equation means an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called a differential equation. And ordinary differential equation means one dependent variable and its derivatives with respect to only one independent variable is called ordinary differential equation. And second one is partial differential equation. So partial differential equation means an equation involving one dependent variable and its derivatives with respect to more than one independent variable is called partial differential equation. And order means what? A differential equation is having highest derivative is nothing but order. Highest derivative of exponent is called degree. Now coming to types of differential equations. Types of differential equations. So in this now first one is variable separable. Variable separable. So variable separable, and second one is homogeneous differential equations, and third one is non-homogeneous equations, non-homogeneous differential equations, and fourth one is linear differential equations, and fifth one is Bernoulli's differential equations. So before I am going to types of differential equations, first we should discuss about variable separable. In meaning only there, in variable separable means we should convert variables, all x terms, all y terms. For example, I will say first variable separable definition. Now variable separable, general equation of variable separable dy by dx equal to f of x into f of g of y. F of x into g of y. See, variable separable means just we should say simple all x terms, all y terms send LHS or RHS depend on question. Now I am writing. Now 1 by g of y into dy equal to f of x into dx. F of x into dx. So in this LHS only y terms. Here RHS what here only x terms. So whenever a differential equation is of the form dy by dx is equal to f of x into g of y, or one more example also there, dy by dx equal to f of x by g of y. G of y. So here variable separable means what? G of y equal to f of x into dx. F of x into dx. So this is what here variable and separable procedure. Now homogeneous differential equation. So a differential equation of the form dy by dx equal to f of x comma y by g of x comma y. In this case numerator both function x and y, denominator also we have both combined of g and x and y function. A differential equation of the form, it is in the form of dy by dx equal to f of x comma y by g of x comma y. At the same time numerator and denominator is having same degree. So then that differential equation is called homogeneous differential equation. So for example, now dy by dx equal to now x square plus y square by 2xy is there. Here numerator degree is how much here? 2. Numerator degree is 2. Denominator degree is what here? Here also 2. A differential equation of the form f of x comma y by g of x comma y with the same degree is called homogeneous differential equation. So working rule for a homogeneous differential equation. Now working rule. See in this case two cases. Now case 1, see whenever a differential equation is have dy by dx is equal to f of x comma y by g of x comma y is given. So that time we should do what here? Put y is equal to vx. Now we should derivative differentiate with respect to x. Now y derivative what? Dy by dx, that equal to, here v is function, x is also function. So whenever two functions are there, then product of the two function derivative means we have formula dy by dx of uv equal to u into dy by dx of v plus v into dy by dx of u, or you can write uv dash plus uv dash plus vu dash. Okay, uv dash plus vu dash. So we can apply same formula here. Now v into d by dx of x plus x into dv by dx. Now dy by dx, that equal v plus, see d by dx of x value how much? 1. So 1 into v is nothing but v. Now v plus x into dv by dx. So this is the first case. So in second case, now case 2, in second case, dx by dy, listen Anna carefully, dx by dy means here dy by dx is, in LHS dy by dx and f of x comma y by g of x comma y, then we should take put y equal to vx, then differentiating with respect to dy by dx, v plus x into dv by dx, then substitute, then simplify, we are getting answer. So in problem that I can explain clearly. So whenever a differential equation it is in the form of f of dx by dy equal to now g of x comma y is given. We should take put x is equal to vy. Now we should derivative with respect to y. So what you will get here now, dx by dy that equal to v plus y into y into dy by dy by v into dy by dx, then y into dv, now dv by dy. So then substitute in given differential equations, we are getting a solution. Okay, this is the homogeneous differential equation. One example, this is the basic case 1 and case 2. So homogeneous differential equations, case 1 and case 2. Now non-homogeneous equation, just working rule, non-homogeneous differential equations. Non-homogeneous differential equations. Non-homogeneous differential equation. A differential equation of the form, dy by dx equal to ax plus by plus c by a1x plus b1y plus c1. See here, without constant it is a homogeneous differential equation. Without constant, with constant, that is what here, non-homogeneous differential equation. Non-homogeneous differential equation, we have 3 cases. Now case 1 is b is equal to minus a1. So whenever a non-homogeneous differential equation is given, first we should observe, if you are getting b is equal to minus a1, both values are equal, then we should do what here in first case we should do, I can explain, each case I can explain one problem also, just basically I am telling here, dy by dx equal to given non-homogeneous differential equation is satisfied this first case, then what to do, just you can write same given differential equation is as it is, just you can write minus a1 into y plus c by a1x plus b1y plus c1. Then you can do cross multiplication, then IBS, integrating on both sides. Now we are getting, after simplification, we are getting what? Solution of this non-homogeneous differential equation. And case 2. Now case 2 of a non-homogeneous differential equation. Now whenever a by a1 equal to b by b1, a by a1 equal to b by b, a by a1 equal to b by b1, comma b is not equal to minus a1. These two conditions are satisfied whenever one non-homogeneous equation is given. If you are getting a first case is not equal, means b is not equal to minus a1 and a by a1 equal to b by b1. If you are getting these two conditions, that problem is belongs to case 2. So case 2 how to do? Just for example, I will give one problem. So dy by dx equal to x minus 2y plus 4 by 2x minus 4y plus 10 is given. Okay. So in this case, now dy by dx that equal to x minus 2y plus 4 by, here 2 is take common, x minus 2y plus 10. Now in this case we should take repeated what? Numerator and denominator x minus 2y. Here also x minus 2y is there. Now we should take put x minus 2y equal to some t. Then after derivative, then simplify, we are getting answer. So this is just basically how to do. Whenever one non-homogeneous equation is given, first how can you identify? With the constants. Okay, with constant. For example, same. For example, look like dy by dx equal to x minus 2y plus 4 by 2x minus 4y plus 10 is given. If you are getting b is equal to minus a dash, if you are getting b is equal to minus a dash or a1, then you can substitute in place of b, you can write a1, then simplify, then just cross multiply. In case 1, we should do what here? Only cross multiplication. Then each and every term we should apply integrating on both sides. We are getting what here? Case 1 solution. And case 2, how can you identify case 2 means? If you are not getting b is equal to minus a1, and it means b is not equal to minus a1, and a by a1 equal to b by b1 is there. That is what here in non-homogeneous equation. Second case how to do? Just whenever one example problem, this is, you can, if you one problem is there, you can write here repeated is there x minus 2y, here also x minus 2y means I can take 2 is take common, x minus 2y plus 10, then put x minus 2y equal to t, then after derivative, then given equation 1 becomes, then simplify, then variable separable, then integrating on both sides, will get answer. This is the second case. Now coming to third case. Now third case, listen on a third case. I can explain clearly, you don't worry about that. If you have any doubt, you can ask after the class. So see, listen on carefully. Now dy by dx equal to ax plus by plus c by a1x plus b1y plus c1. This is a non-homogeneous differential equation. Now what is the difference of non-homogeneous and homogeneous difference? What? Homogeneous equation is also having numerator x and y terms and denominator x and y terms except to constant. Whenever a differential equation is having numerator and denominator with the constant is there, that is non-homogeneous equation. Homogeneous x and y terms, at the same time degree also should be equal. Here x power degree how much? Both are linear equations only. In non-homogeneous also we have linear equations, okay, but with the constant is there. Here without constant is homogeneous, with the constant is non-homogeneous differential equation. So in this case, this is very important, case 3. Now case 3 means b is not equal to minus a1, and one more is a by a1 is not equal to b by b1. So whenever a non-homogeneous equation satisfies these two conditions, so then that problem is belongs to case 3. So case 3 working rule, what? Working rule, case 3 working rule is, if you take put small x is equal to capital X plus h and small y equal to capital Y plus k, and small dy by dx equal to, you should write capital dy by dx. So this is the working rule for third case. In place of small x, you have to write capital X plus h. In place of small y, we should write capital Y plus k. In place of dy by dx, we should write capital dy by dx. Then substitute in this. After simplification, we choose constant terms. After solving, we are getting some h and k values. Again, we are getting what here? And one homogeneous differential equation after simplification. So after getting, you are getting, I think after conclusion we are getting what? Now I am writing capital dy by dx equal to x plus 2y by x 2x plus y. For example, I am giving one example. See, after simplification we are getting this. So now tell me, it is a homogeneous or non-homogeneous? Homogeneous only. How can you know? Numerator and denominator with x and y terms, and degrees, here also 1, here also 1 is there. So a differential equation is having dy by dx is equal to f of x comma y by g of x comma y. At the same time degree also same is there, then the differential equation is called a homogeneous differential equation. Now we should take in LHS, we should observe based on in homogeneous, whenever a homogeneous equation is homogeneous differential equation is given, first we should observe LHS. LHS dy by dx is there. Then what to do? Put capital Y is equal to Vx. Already I have told Nana. So in homogeneous we have two cases. One case is dy by dx is equal to f of x comma y by g of x comma y is there. That time we should do what? Put y is equal to vx. Here capital X, capital Y terms are there. Then you can take capital Y is equal to vx and derivative with respect to x. Then what you will get now? Dy by dx equal to v plus x into dv by dx. After substitute, then variable separable, then integrating on both sides, we are getting answer. This is the concept for a non-homogeneous differential equation. Now coming to next linear differential equations. Linear differential equations. Linear differential equations. Just homogeneous differential equation means a differential equation of the form dy by dx is equal to f of x comma y by g of x comma y, and at the same time same degree, numerator degrees for example 2 is there, 100%, denominator degree also 2 only. Now coming to linear differential equations. Linear differential equations. A linear differential equations, it is in the form of a first degree linear differential equation of the form dy by dx plus py equal to q. A linear differential equation, we have two cases, and it means in this also we have mainly two. This is the first one. A linear differential equation of the form dy by dx plus py equal to q. Here p is nothing but functions of x only functions of x, and p is always having x functions, and here q is also having what here x functions where, so I can explain one more time clearly. A differential equation of the form dy by dx plus py equal to q, where p and q are functions of x or constants only, not y terms only. See, p and q are functions of x or constants only. Then the differential equation is called linear differential equation. For example, I will give one question. See, dy by dx plus 2xy equal to 4x is given. Listen Anna carefully. So I can write this is a compared to this. Now dy by dx plus 2xy equal to 4x. Now here in place of p is what here? Functions of x only. Here only x function. This is x function only. And here what here in RHS also x function. So this is what here dy by dx plus py is equal to q is a first order linear differential equations where p and q are functions of x or constants only. This is I can say linear in y anta, linear in y. This is linear anta dy by dx, y means linear in y. This is what linear in y differential equation. And coming to, in this case we have two cases are there. Two cases. The first case is I dot f. So what is the meaning of I dot f? Is nothing but just integrating factor. I dot f is nothing but integrating factor e to the power of integral of p dx. So in case 1 I dot f means integrating factor equal to integral of e to the power of integral of p dx. Now next second case. Second case is a general solution. General solution is y into integrating factor equal to q into integral of integrating factor into dx plus c. So this is the general solution of linear differential equation. Okay, this is the one linear in y. This is a linear in linear differential equations. We have two. One is linear in y and one more is linear in x. Linear in y, how can you identify linear in y? Just dy by dx. Dy by dx means dy is there, that is called what a linear in y, where p and q are functions of x are constants. See, observe here. Here p value what here? X function with constants only. And here RHS always, whenever a linear differential equation is given, first immediately we should observe LHS dy by dx is there. Immediately we should observe in RHS x function is there or not there. 100% here dy by dx there. 100% in RHS should be have only x function with the constant. Now this is what a linear differential equation in this linear in y and linear in x. Now linear in x. Linear in x. Now linear in x. Linear in x means a differential equation or a first degree differential equation. A first degree differential equation of the form dx by dy plus px equal to q. Listen Anna carefully. So dx by dy plus px is equal to q, where p and q are functions of y or constants only. Constants only. A first degree linear differential equation or a first degree differential equation is of the form dx by dy plus px is equal to q, where p and q are functions of y or constants only. So for example, I will give one question. Now dx by dy plus 2y into x, that is equal to 8y is given. See, observe here, this is first we should observe what here, dx by dy is there, immediately we should observe RHS only y function only with constants. Okay, so that is what a linear in x. Here p value is what here 2y and q value is what here 8y. So based on same, similarly we have two cases. In this first case, in this first case, listen Anna carefully. In this first case, now integrating factor equal to e to the power of integral of p dy, and general solution. Next second case, general solution y into integrating factor equal to integral of q into integrating factor into dy plus 6. So this is the general solution of given linear in x problem. Okay, so based on this exercise we have totally in differential equations, mainly differential equations, order and degree. Order is nothing but highest derivative of given differential equation is called order. So degree means highest derivative of exponent value is called degree, and order of the differential means ordinary differential equation means one dependent variable, one independent variable. Partial differential equations means what? One dependent variable, more than one independent variables. Next, next what? Variable separable. A general equation of the form of variable separable means dy by dx is equal to some f of x into f of y is given. We should write all x terms, all y terms one side. Variable separable and means what? Variable terms once. For example, x and y are both variables are there. X variables one side, y variables one side. Then after that we should take integrating on both sides. Then we are getting answer. That is variable and separable. And homogeneous differential equation means a general equation of the form of a differential equation of the form of dy by dx is equal to f of x comma y by g of x comma y at the same time same degree, then it is called homogeneous differential equations. Homogeneous differential equations are mainly two cases. If you are getting dy by dx is equal to f of x comma y by g of x comma y is there, immediately we should take put y is equal to vx. How can you know? In LHS dy by dx is there, immediately we should take put y equal to vx. And in second case what, dx by dy is there, then we should take immediately put y is equal to put x is equal to vy. After derivative then simplify, we are getting answer. So homogeneous. Non-homogeneous means what? Numerator and denominator both are linear equation, but with constant is there. Degree same but with constant. So in this case we have two cases. Case 1, b is equal to minus a dash or a1 is there, immediately we should do cross multiply then integrating on both sides. And second case, if you are not getting b is not equal to minus a1 and a by a1 equal to b by b1 is there, immediately we should do what here? So depend on question, based on question only we should do very easy, but conditions are more important. First case how to do, second case how to do, and third case how to do. Already I have told working rule. And linear differential equations, mainly linear in y and linear in x. Linear in y is nothing but dy by dx plus py is equal to q, and integrating factor formula is I dot f is equal to e to the power of integral of p dx, and I dot f is equal, general solution is y into integrating factor equal to q into integrating factor into dx plus c, where in linear in y general solution. And linear in x means what? Whenever it is in the form of a first degree or first order differential equation of the form dx by dy plus px is equal to q, where p and q are functions of y are constant is there, that is linear in x. Then example, then working rule. Case 1 is integrating factor equal to e to the power of p dy, and case 2 is nothing but y into integrating factor equal to q into integrating factor into dy plus c. So this is the homogeneous and order differential equation definition. Based on differential equation definition, we have two, ordinary and partially. Next after that, order. What is the definition of order? And based on how can you identify a differential equation is given, how can you identify order? Means highest derivative of the differential equation is called order, and degree means highest derivative of power or exponent is value what? Degree. Now coming to, we have some based on this concept, we can do one question on first. So linear in x, linear in y problems, just concept is over. So based on linear in x, linear in y, I will give one example. One example, see, linear in x, linear in y, one problem. Yes. See, listen and careful, right? One question. Find integrating factor, right? One example. find integrating factor, find integrating factor of 1 plus x square into dy by dx plus y into e to the power of tan inverse of x. 1 plus x square into dy by dx plus y equal to e to the power of tan inverse of x. 1 plus x square into dy by dx plus y equal to e to the power of tan inverse of x into dx is given. See here, a differential equation, first we have to write solution here. Now given 1 plus x square into dy by dx plus y equal to e to the power of tan inverse of x. Yes, listen carefully. See, so this is what here, find integrating factor. Integrating factor means linear differential equation. This problem is belongs to linear differential equation. So in linear differential equations we have mainly linear in x, linear in y. First we should observe linear in y or linear in x we should observe. So depend on what here? So dy by dx, immediately we should say what here, that is linear in y. So linear in y means linear in y form what here, dy by dx plus py equal to q form. dy by dx plus py equal to q form only. So in this case in formula dy by dx coefficient is 1 only, but here dy by dx coefficient what here, 1 plus x square is there. So we don't want 1 plus x square. So throughout dividing by 1 plus x square on both sides. Okay. Now dy by dx plus 1 by 1 plus x square into y, that equal to e to the power of tan inverse of x by 1 plus x square. 1 plus x square. See, whenever a differential equation is given, then find integrating factor. Integrating factor means immediately you should observe what a linear differential equation of the form problem, this one. So in this we have linear in x and linear in y. Linear in x form what? Dy by dx plus py equal to q, and one more is dx by dy plus px is equal to q form. But observe here, both linear in x or linear in y, coefficient here dy by dx coefficient is what? 1 plus x square is there. So we don't want 1 plus x square term. So then what to do? Dividing 1 plus x square on both sides. So 1 plus x square by 1 plus x square, both terms will be cancelled. We are getting dy by dx plus now 1 by 1 plus x square into y equal to e to the power of tan inverse of x by 1 plus x square. Now it is in the form of dy by dx plus py equal to q form. Okay, it is in the form of dy by dx plus py equal to q form is there. Now in this case, what is the value of p here? 1 by 1 plus x square. In place of q value, how much here? E to the power of tan inverse of x by 1 plus x square. 1 plus e to the power of tan inverse of x by 1 plus x square. But actually required what asking? Integrating factor. So okay, we should find out integrating factor. So in linear in y, integrating factor formula what? I dot f equal to integral of e to the power of integral of p dx. Now e equal to integral of p. What is the value of p here? 1 by 1 plus x square into dx. Now that equal to e to the power of integral of 1 by 1 plus x square into dx. Listen Anna carefully. Without formulas in integration or so differentiation, you know formulas, you can do very easy integration. Why? Because integration is nothing but simple definition. The reverse process of differentiation is called integration. So you know differentiation formulas, you can define very easy integration. Both formulas are there, you can do definite integration as well as differential equations also. Okay. Now integral of 1 by 1 plus x square into dx is nothing but tan inverse of x. So this is the integrating factor of given differential equation of the given differential equation. Okay. Now same problem. For example, without integrating factor, just solution is asking. Solution means we should do what? Two methods. Now two cases we have to complete. Now second part I will explain clearly. So first part is okay. First case one, how to do whenever a differential equation is given, how to calculate integrating factor. Now we should do what? General equation of the formula. What? General equation of the solution of linear in y is y into integrating factor equal to integral of q into integrating factor into dx plus c. So this is the general solution. And it means in question is solve 1 plus x square into dy by dx plus y equal to e power tan inverse of x is given. Solve means we have to do case 1 and case 2 also, or sometimes find the solution of this problem, this differential equation. That means what? We should do case 1 and case 2, means integrating factor and general solution. Okay. Now here, now y is equal to integrating factor how much? E to the power of tan inverse of x. That equal integral of q. What is the value of q here? E power tan inverse of x by 1 plus x square into so integrating factor means what? E to the power of tan inverse of x into dx. Just I am writing formula. So in place of integrating factor, we know e power tan inverse of x. In place of q, you know the value of q, e power tan inverse of x by 1 plus x square. Then just in place of q value, I am substitution, and integrating factor also just substitution is over. Then next step, how to do? Just listen carefully. Now y into e power tan inverse of x, that equal to, see, integral of e power tan inverse of x into e power tan inverse of x. I can write e to the power of tan inverse of x whole square by 1 plus x square into dx. 1 plus x square into dx. See, already we studied in integration. So whenever one integral function is given, first we should observe 3 points, mainly 3 points. The first point is, whenever one integral function is given, first we should observe 3 points. The first point is, so direct formula possibility is there or not there? First point, direct formula possibility is there or not there? If it is there, directly you can apply, then we'll get answer. It is okay. If it is not possible, then go to second point. Second point is we should do what is substitution method. Method of substitution means whenever one integral is having two functions are there, so whenever one function is equal to suitable substitution means for example, I will give one example also. Integral of sine of x square plus 1 into 2x into dx is given. Integral of sine of x square plus 1 into 2x into dx. See, sine of x square plus 1 is the one function and 2x is the one more function. So method of substitution means what here? We have to take suitable value is t. For example, if you take sine of x square plus 1 is equal to t, after derivative we are not getting 2x. Sine derivative what? Cos. So this function, first function is failed function. So we are not taking. If you are taking first function is taken as t, After derivative of that function, we are not getting 2x. Cos will come, cos, then after that 2x will come, but exactly here cos is not there. And coming to second, if you take 2x is equal t, we are not getting sine. Then what to do? So we should modify the problem. How can you modify? See, now we should take a, put x square is x square plus 1 equal to t, then a derivative with respect to x. Now 2x into dx is equal to dt. Now given integral becomes integral of sin t into 2x into dx. Can I write what here? Dt. So integral of sin x into dx, formula what? Minus cos x plus c. So that equal to minus cos t plus c. So after evaluating this integral function, we can substitute the back value of t. What is the value of t I am taking? X square plus 1 plus c. Listen Anna, very important this point. So whenever one integral function is there, immediately we should observe direct formula possibility is there or not there. If it is there, okay, no issue. If it is not there, then go to second point. Substitution method is exist or not. Substitution method, how can you know two functions are there or not there? If it is there, so one function derivative is second function getting or not getting. If we are getting is okay, then apply substitution method, then we are getting answer. Substitution method also not possible. For example, first function, after derivative of first function, we are not getting second function. Or if you are taking second function equal to t, we are not getting first function. So here both are not satisfy the method of substitution. Then what to do? We should modify the problem. So how can you modify? We should observe carefully. Sine derivative is direct sine of x square plus 1 derivative. We are not getting directly 2x. Cos will come. So that's why. So first one is not suitable, t. And second function 2x. If we are doing 2x is derivative is nothing but we are not getting sine. So that's why something is there. The something value is nothing but we should observe carefully bracket terms. Mainly bracket terms. X square plus 1 is there. Yes, we should take x square plus 1 is equal to t. After derivative we are getting what? 2x into dx. Now method of substitution is exist, then simplify, get answer. Now coming to here, look at here, all of you listen carefully. So integral of e power tan inverse of x whole square by 1 plus x square into dx is given. First I am asking, first point is direct formula possibility is there or not there, but 100% is not there. Why? Because we don't have formula. E power tan inverse of x whole square by 1 plus x square, we don't know. And next method of substitution we should observe. The second point is method of substitution means how many functions are there. First we should observe. So e power tan inverse of x whole square is there and 1 by 1 plus x square is there. In this case two functions. So which one is you have to take suitable t, means which function is you have to take t here. If you are taking, I am writing here, put tan inverse of x is equal to t. Now differentiate with respect to x, 1 by 1 plus x square into dx equal to dt. Okay. Now y into e power t equal to e to the power of e power tan inverse of x is nothing but e power t whole square, 1 by 1 plus x square into dx is nothing but dt. Now y into e to the power of t, that equal to integral of e to the power of 2t into dt. So we have one standard formula, integral of e power ax into dx is equal to 1 by a into e power ax plus c. So y into e power t equal to e power 2t by 2 plus c. So after evaluating this integral function, you have to write what? Back value of t means y into e power tan inverse of x equal to e to the power of 2 into tan inverse of x by 2 plus c. This is the solution. Just today we discuss only just basic concepts. So every concepts I can explain each and every problem. Thank you. If you anybody have doubt, you can ask. No issue.
Number scroll అవుతుంది ఒకటి స్క్రీన్ పైన దాన్ని కాల్ చేయమని చెప్పండి, వీళ్ళు ఆన్సర్ వీళ్ళు
Okay. Okay, thank you students, thank you.
థ్యాంక్ యూ సార్. మీరు డీటెయిల్స్ అడిగి